Alright, lads, we're starting. So, we're going to be in our documents. Let me just make sure the audio is working. Okay, looks like audio is working. Okay, we're going to create a new document. So we're going to make an oil rig to demonstrate mating and assemblies. If you aren't quite sure about 3D modeling, you can always go back and watch the previous streams. And ask questions in the Discord or in YouTube chat. So oil rig seems to have a pivot point right here. Then this pulls down and up. What we'll instead do is an oil rig like this, where a thing rotates and it pushes it back and forth. We're going to move this up and it's going to rotate 360 degrees, and then this will attach to that. So first we're going to make kind of the pickaxe part of the oil rig. So we'll just say like a line here. It's like one inch, 8 inches. Now typically you want to have your part defined off the center, but we're not going to do that because we're rebels. What we'll instead do is just have a square. We're going to make this perpendicular. And then we're going to make the center of this, or the midpoint. Coincide, and where's midpoint? Midpoint. Boom, boom. Okay, now it's kind of attached. And then we'll do a line upwards a bit. Then we'll do a spline. Do another spline. Now I'm double clicking to end the spline. Make it look oil rig like. That's good enough. Clearly it's the same. I guess we'll just do that. Alright, that's good enough for me. You just make it just needs to be kind of sticking out, that's all. Okay, and then that attaches to the bottom. So we'll go ahead and find a better image. No, looks like that's the best image we got. So we've got that. We'll extrude that out by like 1/2 inch. But okay, and then we'll make another part. We'll make this kind of base that it stands on. So kind of a trapezoid. Make those equal by hitting E, and dimension one of them is like 3 inches. And then we'll do a nice trapezoid upward. Make these lines equal. And define this one as like 12. There we go. Can I change this? Oh, I can. Make that, yeah, that works. And then we'll do, let's see. Do kind of like this. We'll just freehand it. And then we'll go, how does it connect there? Make those parallel. Yeah, those are parallel. We'll make the distance between them be about 1/4 inch. Move that up a bit. Then we'll do the same thing again. Mouse over that line, parallel, 1/4 inch apart. Move it down a bit. Do the same thing again. Parallel, 1/4 inch apart. And then we'll just freehand some lines to go across. This isn't to demonstrate modeling practices. This is more of a to demonstrate mating. This is just an artistic piece at best. So we don't have to worry about it being terribly accurate. The goal here is to learn how to mate assemblies, not to model properly. I did something wrong. Go back to our sketch. We will offset these 3 lines. Oh, I hit escape. How was I supposed to do that? We will offset these 3 lines. Enter. Then -0.25. There we go. Now I can extrude this. I made another mistake. I'm quite tired today. Gotta connect those right there. We will connect that right there. Now we can extrude it. Now we're only going to be extruding the lines here. Extrude that. Boom. We want to make this a additive part. Merge with all. Actually, no, we didn't make a new part. So we have this new part, but these aren't connected. So what we'll do is we'll Boolean all of these. Subtract all of them. Boolean all of them. Appears to be a bit of a geometry problem right here. We'll Boolean all these. And then we'll Boolean that one. Yeah, seems to be a job problem. So what we'll do as a remedy is just create a sketch right here. We've created an infinitesimal point right here, and that's unacceptable. So we'll just extrude through it a little bit. We'll just add it the other way by like merge with all. There we go. Now I've connected those 2 parts. Okay. So then we'll duplicate this. There you go. Copy part. Now I've got 2 of them. We'll create a sketch right here. And we'll have this line right here. Then we'll use the rest of this geometry. Use. Now I hit U. U for use. Use. Extrude that. Up to face. Then add. Merge with all. Ta-da! Okay, now these 2 are connected. We'll create a... Let me think about this for a bit. We'll create a little protrusion in the middle here. Do a R for rectangle. We will mouse over the middle of these. And go to the middle. Make a 2x2 rectangle. Screw it up. Okay. Now we can go to our assembly and insert both of these. And what we can do is drag this up here. So we're going to do a revolute mate. And I want to have a mate connector right about here in the middle. I can't really do that, so what we'll do instead is create a mate connector on either side. Create a mate connector right here, and then we'll move it by move it in the x-axis by -2. Put it right over there. And then we'll do a revolute mate right here. I selected the whole part. I want it to be just the mate connector. Mate connector here. And then, oh, I did it wrong again. Mate connector. Just click the mate connector in the tree. And then we'll revolute that. You can see it revolutes. Now we can put a limit on it that says like 30 degrees. I don't know. Just keep messing with it until it works. I can simulate that. Okay, we'll go -30. And -60. -180. We'll see how it works. Set that to be a bit more forward. Okay, we'll just set that to 0, and then it should work. So it's starting at -180 degrees, and it ends at 0 degrees. Ta-da. Now we'll actually move that a little bit more forward. So oil rig doesn't actually go all that far. Actually, this revolute mate is entirely, these limits are entirely unnecessary because the limits are going to be defined by the geometry that we attach to it. You'll see in a moment what that means. So we'll go ahead and fix this part right here so that it stays where it is. So this can move, right? But what we want to do is attach something to the back here that grabs onto the back and pulls it down and up. Now, how this oil rig right here does is that it has a separate thing rotating. So what we'll do is we'll go ahead and make that. What we can do is just kind of copy this part and then shrink it a bit. So we'll delete this, copy part, duplicate, and then we'll transform this part to be a bit smaller. We'll scale it. The mate connector will be the center point here. And then we'll scale it by 1/3. Nah, we'll do, yeah, actually 1/3 is good. That's smaller now. And then we'll attach a little spinny thing on here that will rotate. So what we'll do is we'll create a cylinder on this. Make it symmetric. Make it extrude like 6 inches. We'll do a new part so that it's a separate thing. What we'll first do is do a remove. And then we'll do, on top of that, we'll do an add. So then we'll add symmetric. Or a new part, sorry. Symmetric. No, we don't want this symmetric. What we want to do is have it go like 4 inches in that way. And then second in position, make it go 6 inches the other way. Because if you look at it, hold on, I did something wrong. I think it's 5 inches. We scaled this down by 1/3, so it's not going to be quite accurate. Oh, sorry about that. So instead, we will have the sketch. We'll make a plane in the middle here. We'll have the midplane of this point. No, not this point. This point and this point. Boom. And then sketch. Use this. And then we can extrude this symmetrically. This in the middle here. Yep. Make a new part. Symmetric. 6 inches. Is everyone understanding good so far? We doing alright? Everyone kind of following along? Extrude this part. Hide this sketch. Sketch doesn't want to hide itself. So now that we have this, we can attach like a spinny thing onto here. So we'll go ahead and just model a... So this is a 2.5 inch hole, or 1/4 inch hole, sorry. And we'll just model a spinny thing to go in here. It could just be a bar, it really doesn't matter. We will add a 2.5 inch hole here. Or no, sorry, a 1/4 inch hole here. We'll shrink this down a bit, and then we'll add one to the other side. Boom. Extrude that. 1/2 inch. Okay. Now we'll go ahead and try and put this all together. So we'll import our other 2 parts. Okay, so we'll first we'll do a revolute mate. Actually, we want 2 of those bars right there. How thick is this? Because that goes... We want this to be in the middle. So I want the coordinates of this. I want this to be kind of in the middle there, between it. So what we'll do is have this... We'll start from here. So we'll create a mech connector on... This isn't going to be too accurate, but we'll just do it from here to here. And then flip it. I'll do a revolute mate from here. Actually, no. What we'll do is create a... Yeah, actually, no. We can do a revolute mate from here to here. And then offset it by 1 inch. There we go. So we'll offset, 1 inch. And then we can fasten, or do a revolute mate, another revolute mate. We want it to select the middle of that. This is just to demonstrate. This really isn't designed to be accurate. This isn't designed to be like perfect at all. This is just to demonstrate the points of mate connectors. So once we have that, we'll kind of move this into a good spot. I'm noticing my error all of a sudden. So currently, if I were to fix this right here, move it just a tad bit. Okay, this is good enough. Try to fix this right now. I could move these, I think. No, I can't move these. I need another joint in the middle here. So what we'll do is instead of this bar, what we'll do is we'll have this bar, we'll duplicate this. And then we'll shrink this, we'll make it shorter. So in the sketch, we'll just make these. So how far away? We'll create a line between here. Make that construction. Could do a dimension, but we'll do this instead. Make another construction line. Make these equal. The dimension one of them is, say, like 1 inch. And then we'll shrink this down a bit. Boom. So now we've got another beam right there that we can use. We will insert this, which we just made. And then this right here, we'll get rid of this revolute mate here that attaches these two. And then we'll get rid of the revolute mate that attaches these two. Now I can move this freely. And then we'll do revolute from, okay, no, I did wrong. We want to keep the, so the revolute mate that attaches those two, we want to keep it. This one we want to get rid of. So then we can move that up and then attach those two. So we'll select the middle of this, middle of that, offset it by 1 inch. Kind of want these to be lined up. So we'll say actually, we don't need to offset these. Sorry about that. Because what we can instead do is, because this will, no, we do need to offset it. I was wrong. Okay. What we'll do is instead we'll attach it at the top first. No, I was wrong. Deleted the wrong mate. Okay. So, revolute mate. We'll attach it at the top first so that it's proper distance that we want it. So this will attach to this. We will flip it. And then this will attach to this. Hold on, I think I did it wrong. This right here attaches to this. It might, yeah, it has bad geometry. Okay. So, essentially these mate connectors need to line up. We'll do cylindrical mate. Let's see if that works. Yep, that works. So cylindrical mate is essentially the same thing, except instead of attaching it to the part, it just makes it aligned with the part. So now what we can do is we can rotate this. And of course the measurements aren't right, but you kind of get the idea of what we have going on. So we move this up and down. It's just that rotating. So if we were to hook a motor up to this right here, and then, you know what? These parts you could easily 3D print and make a model of if you wanted to demonstrate that. So all we would have to do is attach a motor right here and just move this like the tiniest bit. But you see it only moves just a tiny amount, but it moves that a whole lot. So there's a whole lot of torque in what would be this motor, but very little movement. So I'd have to have a really high torque gearbox to be able to move this properly. So you can kind of see the fruits of our labor, kind of how that works. Any questions? Anybody got any questions? Okay. Any questions? Got anybody with questions? Any singular person? It's important to ask questions, even if they're small, because that's the best way to learn, is to ask. Still telling me I have no people in here, but I disagree. Give me just a brief moment. I'm gonna go grab something. I'll be back in a tiny amount of time, like 5 minutes. Alright, we're back. We are good to go, I think. We'll go over each individual mate and everything that it does. Okay, so now that we've kind of shown a demonstration of what assemblies and mating can do, albeit a really bad one, still a demonstration nonetheless. We'll go ahead and discuss each individual mate and what it does. So a fasten mate essentially will just take I'm going to insert a whole bunch of these. A ton of them. Move them around a bit. So a fasten mate simply just takes mate connector. So these auto-generated mate connectors are just put on, but you can make your own mate connectors. So if I wanted a mate connector like in the middle right here, I could say mate connector, put it in the middle here, and then realign it, or not realign, move it like an inch up, or an inch, 2 inches down, you know, whatever, and it would move it. Now this isn't aligned. Is this perfectly vertical? Yeah, it is. Like say, move it 2 inches up. Where's it at? Where's it going? Ah, I see. The axis is that way. It's taking the axis of the actual mate connector. So what I'd instead do is say the y-axis, which is this little green mark here. Let's say like 2 inches up. Boom. No, -2. Want it to be up. And it's like, oh, okay, now I've got a mate connector here. I can say fasten. So fasten just takes 2 mate connectors. We'll go ahead and select the mate connector in here. And then I want to have it fastened to, like, I don't know, the middle of this. I can rotate it. And it just attaches these 2 parts together. Just puts them together. Now when I move one, I move the other. Just puts them together. That's all it does. Perfect for making a robot chassis. Revolute mate is, we already demonstrated that. You take 2 parts, and it will it'll stick them together, but it'll also make them rotate amongst one another. So if I take, I fix this, now I can rotate. Oh no, I didn't fix it. Fix it. Now this will rotate. So it sticks them together, and it will rotate, allow them to rotate. Cylindrical mate is that, but and we did it here. It'll essentially just make 2 objects rotate near one another. So if I were to delete this part right here, I can move this up and down and rotate it. So it just makes them whatever cylinder you selected, whatever mate connector you selected. So in this case, we're not actually selecting the cylinder; we're selecting the mate connector of that circle right there. So it just creates a point in the middle, and it's rotating around that point. And so it just means that those 2 points are going to be aligned on the whatever axis they're aligned to when you have them. So I can move this and rotate it, so it's perfect for, like, I don't know, an engine or something like that, you know, like a piston engine or something, whatever. So when we tried to create this without that, because these 2 weren't really defined, we didn't really have a defined measurement between here, I tried to mate this to this, and it was trying to move this part over here when it's attached to this part. That one works. So a cylindrical mate is perfect for that, something like that, where you haven't perfectly measured it out, but you still want to do it. I also like to mention that S pulls up a quick menu, which is pretty nice if you're speed modeling or doing a CAD-a-thon. Let's keep that in mind. Is my stream still going? Seems like it is. How many people do we have? I mean, I see that Bryant is here, but do we have any more people? Make yourself known. That'd be pretty nice. It's telling me that I got no people. What the heck? But there's somebody in the chat, and then I'm sure there's more people than that. Anyway, what was I going to say? Oh yeah, so your slider mate is just what it does is it takes, like, if I had, I'll insert this again. I'll insert that right here, and then this right here. What it does is kind of like a cylindrical mate, but what it does is just have two mate connectors. It'll allow you to, let me fix this and fix this. Is this fixed? Yeah. Okay. Nope, that's not fixed. So that's fixed. It just lets you slide. Just slides, that's all it does. Your planar mate, let me just make sure of this. I think what this allows you to do is okay. Honestly, I'm not quite sure what the planar mate does. I'm gonna look that up real quick. Thought I'd just align it to same plane, but not quite sure. I'm gonna be real with you. We'll go over that next next meeting. I'll learn these a little bit better. I haven't ever had to use anything but fasten Revolute. I haven't had to use anything but fasten and then Revolute or cylindrical for I have occasionally had to use a ball mate, but or a pen slot mate, but not really anything else. You've got parallel mates. You've got your snap mode, which is like when I insert a part. Snap mode will allow me to automatically like connect things together. Hold on, if I enable snap mode and show mates mode, snap mode will just let me like snap the parts together. It should be let me like select the mate connectors. So it should be doing that. It's not doing that. Let me refresh the document. But snap mode, what it's supposed to do is let you insert a part and then just snap it to whatever mate connector you're looking at. So if I enable snap mode, and then let me see, maybe I have to drag a part. Yes, okay, so it's when you drag a part. So I grab this. I can just snap it to that mate connector. So it's not when you insert a part, so I can just snap it right here, and it'll automatically snap it to that mate connector. So it just lets you drag stuff and fasten it really quickly. These things we'll go over. There's assembly patterns, there's circular patterns, there's like gear relations, which are like teeth and stuff like that. Screw relations are essentially just for screws. It lets as something moves downward, like if I have, let me just pull up my pen real quick. If I have a screw right here, there we go. It's got like threads. I don't know, it's a horrible screw, but you get the point. And so then I have like a slot for that, and I want to model it going down in that slot. What I'll do is have a slider mate so that as it moves down, it'll rotate. Or not slider mate, the screw relation. As it moves downward, it'll rotate. So that just lets you simulate that a little bit better. You can create your own custom cam, I guess, or something like that with it. Make a CNC machine or whatnot. Linear relation, makes it something aligned. Create Pro Studio in context is the greatest thing ever for making, for updating parts. What it lets you do is it just, so I'll create my part studio and then I'll select like whatever origin I want. So I'll just select this origin right here. I'll go ahead and put the ink there. So I can just have that origin, hit the check mark, and then it will create a part studio that just lets me like define. Like I can create a definition off of this. It just puts it in my part studio. And where this is really useful is I can create a part studio around, I can just have the robot and then create a part studio around the robot. So if I need to update a part, it'll let me just edit, essentially just create a part studio on top of the robot, which is really nice. And I can just butcher it however I need to make it work properly. It's very useful. Probably one of the best tools you can have for refining specific part designs. I think that we've hit most everything that's important. We'll hit a little bit more next week. I'll re-knowledge myself on some of the more niche mate connectors. Real quick, we'll just go over a couple simple 2D robot designs that I said I'd do last week. So, I think Carbo Robotics. Yeah, 7763. Their off-season designs that they showed me I thought was pretty neat. I think it was a 32-inch chassis. They, I was talking to them about 4 bars, and they're like, I wonder if we could reach mid with a 4 bar, because obviously you can reach low. What a 4 bar is essentially... Actually, I'll just demonstrate it in the assembly. If I have 4 bars, right? Move this over here. So if I have this bar, if I like say, okay, revolute this onto that middle right there. And then I'll go ahead and fix this. Yeah, these are 2 bars, they're connected, right? And then if I have this, like that, connect that revolute. These 2 are attached to the middle. Now I have a bar that I can kind of rotate like this, right? But if I had this as an intake, this would be floppy. That wouldn't be good. But with a 4 bar, what I can do is, let's say this is like what my robot's coming off of. Why it's called a 4 bar is because you need 4 bars to do it. That revolute, we will fix this. This rotates, and then, oh. Catch that to that, flip it. Unfold it. Now, if I do a revolute mate here, and here, then do another one. It might not define properly. No, it might not define properly. No, it didn't, because I did it wrong. We will flip that. Nah, it's not going to work. I think I did the geometry just a bit wrong, but if I make this a cylindrical mate, maybe it'll work. There we go. So this is fixed, right? Now, when I move this line right here stays perfectly vertical. And this is really good because if I said this was like my robot, right? So here's my robot. Here's my wheels, right? Good thing about it, it folds back up really concisely, right? So if I had this like a little farther back, well, let me just use the power of movie magic to move this a bit. So this could fold up back here, and then I could have like an intake right here. You know, like the cone goes in here, and then the cube will go in here, something like that. And then I can have this fold out, go pick up, you know, whatever object I have on the ground here, get my little cube or whatever, and then it folds back up. Now, a 4-bar also works the other way. So if I rotate myself, right, this is my thing. If I go, say, okay, now my 4-bar is the entire robot, right? So this was like just my robot. We'll clear that. So this is my robot, you know? And then I was like, I don't know, this was my robot, actually. No, I did it wrong. So this is my robot, right? And then I said, okay, this would fold up, right? And then I'll have my intake, you know, like this. Grab a cube or whatever. Then it can fold out and go the other way. And then when it goes up here, let's say this was like my, you know, my stairs or cones or whatever, it can, you know, if this sticks out a little bit, right? So this sticks out a little bit. When I fold it back down, it's sticking out right here. Right? And then when I fold it back up, it's sticking out right here. So, I mean, that could easily, you know, go place on mid. And what we discovered is that with the robot, you can actually place it on high if you make the tolerances really tight. You have to be within a literal, like, centimeter of tolerance for how the bars are positioned. But I'll go ahead and show that right here. I think that... Is it working? Audio working? Yeah, everything's working. So we'll go over here to their robot. So this was kind of the 2D prototype that they had. And we'll go to the sketch. We'll align ourselves to the right plane. Nope, the back plane. Flip ourselves. So they had a robot that they were like, okay, this folds up, right? And it's like, okay, it stays within perimeter, right? Just barely. Just oh so barely stays within perimeter, right? Okay, let's say this was like our intake or whatever, right? This strip right here is our intake. Then they were like, okay, this will go here. This 4-bar will be positioned like this, and they just kept messing with it until they got it right. And then, let's see, 23 game manual. So if I go to the grid scoring, where does it show the dimensions? Oh, I messed up. There we go. Should show it somewhere here. Scoring grid. There we go. So top row is 3 feet 10 inches, right, to get to the top. We discovered that if designed perfectly, right, this is a 36-inch chassis. This might not actually be the design. I think they messed it up a bit. Yeah. So, okay, if we make these bars... Gosh. I think this might be the wrong document. Sorry about that. If make this... I want this to be... Okay. Well, the discovery was that if they do it right, if they make everything perfectly aligned, what they can do is have this actually come up. It was like how much? Let's see. It was like 3 feet 10. I think it was 3 feet 17 inches or something like that. If they design a like perfect virtual 4-bar robot that goes like back. Oh, I messed up. It just folds up back into the chassis that it was back here, and then it could extend all the way up and reach that high node. And they didn't even think that they'd be able to do that with a... this isn't a virtual 4-bar. I keep saying virtual 4-bar. It's a real 4-bar robot. It's able to extend up and reach the high pretty easily. And all they would need is just like a winch right here to either pull this back or rotate this bar or something like that. I think we're going to end the lesson there. And if anybody has any questions, you can ask them, email them to me, whatever. Email the megabytes. I'll sit here for like a minute with any questions that anybody has, and then I'll go ahead and leave. I think we'll go a lot more over and in depth and stuff tomorrow. I'll wait ahead and go ahead and wait for questions and things like that for a minute, and then I'll leave. If anybody has any topics that they want me to cover in the next coming meetings, I'm going to be leaving soon, so I'll need people to message me about those. All right, I'm going to go ahead and stream. I think we hit everything that we needed to. We discussed mating, we discussed kind of a little bit of a robot design, and how to kind of prototype stuff. So with that, just when you come up with prototypes, just create a little 2D sketch to try and simulate that, and just go, around that. Anyway, hope everyone has a good day, and see ya.